Hello everyone, welcome to another ArcGIS tutorial. In this tutorial, we are going to discuss 7 advanced geoprocessing functionalities of ArcGIS. Now you can have a look at the list of the types of geoprocessing operations that we are going to discuss on the screen right now, and also by simply checking out the description. And if you would like to skip to a specific one, you can simply do that as well using the provided timestamp. Alright, so the first geoprocessing operation that I'm going to discuss is spatial interpolation using Kriging method. And to demonstrate that, I'm using this elevation points shapefile. I just dragged it and dropped it into my working space. By the way guys, all the data that I'm going to be using for this tutorial can be downloaded using the link given in the description below. So if you'd like to practice these geoprocessing operations by yourself, you can simply download them using the link given in the description as well. So as I mentioned to you guys, we'll first have a look at spatial interpolation of a point dataset. Now some of the applications where this kind of an approach of interpolating values based on point data can be, let's say, to create an elevation model or a surface based on ground survey levels. Now, you know that when a surveyor records the elevation values of a particular land plot, the number of survey points that he or she can pick to represent the topographical variations in the land surface is limited, isn't it? In such a case, we can use these kinds of spatial interpolation techniques to derive a continuous surface, where the values of the points which we do not have the data for will get interpreted based on the available values of the points, and also it will depend on the type of the interpolation algorithm that we use. Now, as I mentioned, we are going to use the Kriging method to demonstrate this to you guys. We have a set of points over here, and these points represent elevation. You can simply open up the attributes table and you can have a look what's going on over here. You can see that we have 37 points and we have a column called elevation, and basically these values represent the elevation which is relevant to each point. Maybe I can simply right click over here and label the features so you guys can quite easily see how the elevation varies across different areas. And if you wanted to create a continuous raster or a continuous surface based on these elevation points, we can simply go to Spatial Analyst Tools, Interpolation. That's what we are going to do basically, Interpolation, and from here we can select Kriging. And right over here you can see a couple of other interpolation methods as well. You have the IDW, Inverse Distance Weighting, Kriging, Natural Neighbor, Spline. For this tutorial, let's go with Kriging. After I double click, we have to input a couple of things. The first thing that I'm going to input is the point feature dataset, and that's going to be my elevation points. So I'm going to simply drag it and drop it over here. And then something that you have to keep in mind is that we have to specify by which value field we are going to define the z values or the height values in this case. So that's going to be the elevation column as you saw just a couple of minutes ago. And I'm going to specify the output location. I'm going to name this as surface.tiff. It's quite important that you specify the file type over here. We are going to generate a raster in TIFF format, so that's why we need to be specific about this particular type, otherwise this tool won't actually work. Alright, once you're done with specifying the name of the output raster and its location, you can move on to these semi-variogram properties. Now for this tutorial, I'm just going to stick with this default settings where the Kriging method is ordinary and the semi-variogram model is spherical. If you would like to get some brief descriptions about the available options, you can actually click over here, and over here on the right side it'll provide you with a very brief list of the options that are available for you to choose from for the Kriging method, as well as the different semi-variogram models available. Now for the output cell size, I'm going to maybe reduce this one to be about 20 meters by 20 meters. And over here for the search radius, I will stick with the variable search radius. Let's say if I were to stick with the number which is already here by default, that's 12. And over here I also can specify a maximum distance. Now if I don't input anything over here, you can see that the default value is the length of the extents diagonal. So I'm alright with that. If not, if you would like to manually enter a value for the maximum search distance, you can simply go ahead and enter that as well. But I'm going to leave this as it is. I think that's about it. And after that, I can simply go ahead and click OK. And after a couple of seconds, you will see that it'll perform the interpolation and it'll provide you with the interpolated raster based on these point elevations. Alright, so this is how the final product looks. You can see that the extent of the raster is basically up until this point from the north, and this point from the south, this point from the east, and this point from the west. So it's basically covering the entire extent of my elevation points shapefile. and you can see that it's providing sort of a smoothed out raster just like this, and the elevation classes are like this. Now if I go ahead and again activate the labels, now you can even double check a couple of things. For example, you can see that the elevation of this point is 311 meters, but you can pick this identify tool and you can select somewhere over here in the raster just to see what sort of a value it has adopted. Over here you can see that the pixel value is 306, so it's quite close to 311. And similarly, if I pick a low point like this, let's say over here we have 47 and over here we have 66. So let's say if I were to pick a point over here, it should be something within the range of these values, and that's 57. So you can see how the process has utilized this limited number of points in order to generate a smoothed out raster like this. And of course you can go ahead and edit the properties, especially when it comes to the symbology. You don't really necessarily have to have the default option for classifying the raster. You can, let's say, even if you'd like to increase the number of classes, you can do that as well. Let's say we can select 20 classes, and even you can change the color scheme like this, and you can select apply, and you can see that how that color scheme gets applied, as well as the divisions over here increases accordingly as well. Or if you would like to have a stretched color scheme with a color ramp like this, you can use it as well. Well, I would like to flip this and show the lower elevations in dark blue color and the high elevations in, let's say, dark green color, just like this. Alright guys, so I guess you got the basic idea of how to use these interpolation methods, particularly Kriging method for this specific case, to generate a smoothed out raster based on a number of sample elevation points. Alright, so let's move on to the second geoprocessing task that we are going to discuss today, and that's performing a cut fill analysis using ArcGIS. Alright, so what this cut fill analysis tool does, it calculates the changes in volume between two surfaces. Now this figure that I'm going to show is actually a very classic example used to demonstrate this cut fill analysis by estimating the erosion and deposition of a river segment over a specific period of time. Now you can see that the top figure is a section of a river, and the figure below shows a section of the same extracted location, let's say after a couple of years, after it had gone through some morphological changes. And as you can see, some parts in the riverbank has eroded, and the river channel itself seems to have gotten some deposition of sediments. Now if you were to estimate the erosion and deposition changes, well, in this case the erosion can correspond to a cut, and we can consider the deposition as the filled out parts. And we can estimate these volumes simply by making use of the cut fill analysis tool of ArcGIS. Alright, so I'm going to go ahead to this catalog, and over here under this cut fill analysis folder, which you will also get, you can see that there is one raster called elevation. I'm going to drag it and drop it over here, and let me go ahead and close this one out. So this is the raster that I'm going to work with. Now you can see that the elevation varies from 606 meters, that's the highest elevation, up to negative 25 meters, which is the lowest elevation. So it's quite a high range. Let's say, as a hypothetical scenario, after this piece of raster goes through some morphological changes, let's say it just became a flat surface of 200 meters for some reason. So I have to create that raster. Well, one of the easiest ways of creating a raster with a constant value, especially when you have a raster already like this, is to use the raster calculator. Now you can go to the search tool and search for raster calculator, and you can simply make use of this elevations.tiff raster. Now in order to create a constant value, all you have to do is, let's say, multiply this entire raster by 0, which will create a raster with a constant value of 0, and after that you can add the constant value that you would like to specify. Now I'm going to specify the output raster to be elevation 200.tiff and click OK. Yeah, and you can see that quite simply it created a raster of constant value, which is 200 in this case. So what you have to imagine is that the before case is this raster, which has its elevation range from negative 25 to 606, and the after case is that the whole area has been flattened out to create a constant elevation of 200, which definitely involves some cutting and some filling, and that's exactly what we're going to find out through this cut fill analysis tool. Now in order to access the cut fill analysis tool, you can go to Spatial Analysis Tools, Surface, and from here you can select cut fill. And the inputs are quite self-explanatory. Now you have to input the before raster, and that before raster is going to be this elevation raster, and the after raster is going to be the one which specifies the elevation after the cutting and the filling has taken place, and that's going to be a constant 200 elevation value. And I'm going to specify the output raster to be, let's say, cutfill.tiff. We can run the tool simply by clicking OK. And after a while, when the tool runs, this is what you will be able to see. And over here you can see that we have this net gain, net loss, and some unchanged parts as well. So if we go ahead and right click and open the attributes table, and if I double click on this volume tab that you can see over here, you can see that we have some negative volumes over here, and then we have some zero volumes, and after a while you'll be able to see that we've got some positive volumes as well. Now if I were to select these positive volumes just like this, you'll be able to see that it's corresponding to this blue color part, and that's going to be the net loss. And if I were to do the same thing with this zero volume values, you can see that it's not quite apparent, but some pixels actually do correspond to this zero volume value, and you can see that those are unchanged. Finally, if I select these negative volumes, you can see that it's basically corresponding to the red color, which are the net gains. So simply put, if I deselect everything, what you can see over here is that during the process of converting this initial elevation raster into a constant elevation raster of 200, these blue color areas are the areas which have been actually shaved out or that has been cut down, and these red color areas are the areas that needs to be filled in order to achieve that 200 elevation value. And if I zoom in, you will see that these gray color spots are the spots where the original elevation was 200. So it was not necessary to either cut this down or fill it in, because the original value was 200 and our target value was also 200. So these gray color pixels remain unchanged, and that's what you can see over here. So just like this, you can get a very clear idea of what needs to be cut and what needs to be filled in order to achieve this 200 elevation value raster. And this is only a simple case that I have used to demonstrate this tool to you guys, and by using the same principle, you can see that how you can use this, how you can make use of this tool in order to compute your own cut and fill values based on your specific case. Alright guys, so that's about it for this second tool, and now let's move on to the third tool, and that's going to be permanent reclassification of a raster. Alright guys, so the third advanced geoprocessing task that we are going to discuss in this tutorial is raster reclassification. Now I'll be using the same raster in order to demonstrate this process to you guys. And as you can see, we have this elevation raster, and currently this is the color scheme which has been assigned to this particular raster. And as you can see, the elevation varies from 606 up to -25. And let's say if I were to do some sort of a classification, we can actually do some raster classification simply by going to the layer properties, and from here, over here in the symbology, we can select different color schemes. For example, let's say if I go to this classified option, you can classify this raster into number of classes. Let's say from here I can increase the number of classes to 10, and even I can change the color ramp to be something like this. And now if I click apply, you can see that now we managed to classify this raster based on this elevation ranges. Now even if you go to this classify, you can manually adjust these classification bars just like this, so that you can sort of decide how you would like to do this classification. You can see that these numbers actually correspond to different elevation values. Now I can either have them grouped like this, where I could increase the number of splits in the lower elevation ranges, and I can spread these out just like this for the rest of the parts. And if I click OK and apply, now you can see that it's a different classification again. Also, if you go over here to select a classification methods, you can see that it provides you with a couple of a number of classification methods. You can go with equal interval, in which case, based on the number of classes that you specify over here, it'll divide it into equal intervals. For example, you can even increase this to 15. In this case, you can see that the starting range is from 0 to 17.06, and from there it's 59.1, 101.2. So just like that, it reaches all the way up to 606. And if I click OK, and you can see that now it's getting displayed in a different manner based on the classification that we did. Alright, everything is good so far. And just in case if I happen to close this, let's say if I remove this layer, and if I happen to drag this in, just like this, you can see that that classification that we did was not really a permanent classification. It's just a temporary classification that we do in order to visually represent the raster in the way that we want temporarily. So what I'm going to teach you guys is that how to permanently reclassify a raster so that even if you close this raster and drag it back into your working space, it'll be actually classified in the way that you want. So the tool that I'm going to use for that process is called Reclassify. You can simply go over here to this search panel and you can search for the Reclassify tool. And over here you can see under Spatial Analyst, you can find this Reclassify tool. And what you have to do is you have to input the raster first, just like this. And of course we are going to work with the value field because that's the field that's actually corresponding to the elevation values. And over here you can see two columns. We have the old values and the new values. Now you can see that the old values are automatically being categorized from -25 up to 61, from 61 up to 111, all the way up until the maximum value over here. Now let's say for some reason you would like to get rid of all of these values. You can select it and you can delete it. And after that you would like to define your own categories. Let's say from -25 up to 100. I'm going to specify that to be my class number 1. And from 100 up until 250, I would define my class number 2. And from 250 until 500 is going to be my class number 3, and from 500 up until the highest value, and in this case that's going to be 606, as you can see over here. That's going to be my class number 4. And I'm going to select the location to save this raster. I'm going to name it as elevationranges.tif, and that's where I'm going to save this raster. Alright, now if I click OK, you can see that just in a couple of seconds, my whole raster got reclassified into different classes that you can see over here. Now what I'm going to do is I'm just going to get rid of both of these rasters. And if I navigate back to my working folder, which is this raster classification, you can see the new raster that we generated. Now if I just drag this and drop it over here, well, I can click yes. Now you can see that automatically the raster has now been reclassified, and that's a permanent reclassification. You can see that the elevations varying from -25 up to 100 is now displayed by black color over here, and this blue color areas correspond to elevations ranging from 100 to 250, and the green color is showing elevations from 250 to 500, and finally these red color spots are showing the highest elevations, which are actually from 500 to 606, if I can recall correctly. Now this kind of manual classifications can be extremely useful. Now for example, if you're trying to produce a map which shows different flood depths. Now if you were to show your flood depth map using a smoothly varying color ramp, it might be a bit difficult for the reader to sort of distinguish between different depth classes. And in such a case, you can very conveniently use this Reclassify tool in order to delineate the different depth classes according to your preference. Let's say from 0 up until 1 meter, it's going to be assigned as one class, and from 1 meter up to, let's say, 1.5 meters, it's going to be another class, and so on. So that's just one example of how you can utilize this Reclassify tool, and there could be many other applications of that as well. Alright, that's about it for that. And just before we move on to the next advanced operation, I would like to bring to your attention that once you do a reclassification, you actually lose the fine information that you've previously had for that particular raster. For example, if I go over here, and now you can open the attributes table as well, and you can have a look at the different classes, just like this. And now you can see that the area which belongs to this value 1, you only have the number of the count of the pixels. But after this permanent classification, you can see that you really have lost those detailed information about the elevations of each single pixel that you had previously before you did the reclassification. And that's something that you have to understand before you proceed with this. So that's something to keep in mind. Alright, I'm going to deselect everything and let's move on to the next tool that we're going to discuss today, and that's how to perform conditional operations on rasters. Alright guys, so if you're not so familiar with conditional operations, I think you guys can have a look at this diagram. And as you can see, we could come across a case where we have a certain condition, and depending on whether the answer is true or false for that particular condition, we might have different outputs. So the way that I'm going to demonstrate that to you guys is simply by using the same set of raster data that we just worked with. As you can see over here, we have this classified raster of elevation ranges that we just created a couple of minutes ago. And in addition to that, we also have the original elevation raster. You can see this elevation range, which is highlighted by blue color over here, which is actually corresponding to this range number 2. So for all the areas which are actually shown in blue color, I'm going to pick the corresponding elevation value from this elevation.tif raster. That means this raster. But for all the other areas, which includes, let's say, number 1, number 3 and number 4, I'm just going to assign all of those values to be equal to 0. Well, that's the condition that I'm going to work with to demonstrate this conditional operations tool to you guys using ArcGIS. Now the name of the tool is con, which basically stands for conditional operations. So you can simply go over here to the search panel and search for C or N, and it's under Spatial Analyst Tools. If you click over here, you can see even it says that it performs a conditional if-else evaluation on each of the input cells of an input raster. Now over here, in order to demonstrate to you guys, my input raster is going to be my elevation ranges raster. So I'm going to drag it and drop it over here. And if I go to the attributes table, you can see that we have a field called value. So my expression is going to be if the value of my value field is going to be equal to 2, then I would like to pick the corresponding values from this elevation raster. But for all the other cases, and that's basically another way of saying else, that means if this condition is not being sufficed, what do I need to do? I would like to assign the value 0 for all the other pixels. And let me go ahead and specify the output location for this raster. I'll go to the corresponding folder and I'm going to name this as elevation_con.tif because it's going to be a raster. And let's click OK to see what happens. Alright, so I'm going to deactivate all the other 2 rasters, and this is the one that we generated. And let me just go ahead and change the symbology just a little bit. We can use this color scheme. Alright, now I think what we did is clear for you guys. Now if I pick this identify tool and if I select all of these other areas, you can see that the corresponding pixel value is 0, except for these regions, which are the regions which correspond to this number 2 of this elevation ranges raster. And those areas have been filled with this detailed elevation raster, as you can see right over here. So that's one of the examples that shows you how you can use this conditional operations tool in order to work with rasters in ArcGIS. Now of course this might depend on your individual case, and if you actually understand how this tool works properly, you'll definitely be able to use this for your own individual cases as well without any problem. Alright, so let's move on to the next geoprocessing operation that we're going to discuss, and that's going to be how to use the extract by polygons tool. Alright, now I'm going to demonstrate to you guys how we can use this extract by polygons tool. Now you can see that I have imported a couple of things into my working space. We have the elevation raster that we were basically working with all this time, and we also have an additional shapefile called points. Now there's a separate tool called extract by mask, which you can use in order to extract, let's say, a part of a raster based on a defined extent specified by a polygon. But this extract by polygons tool works in a bit of a different way. Now, in order to access the tool, we can just go to our search panel and we can search for it. You can see that it's the first tool over here. Now the things that we can enter in order to run this tool is that we need to have the input raster, and that's not going to be an issue. We have this input raster over here. And if I draw your attention to this part over here, the extraction area. Now this is one of the cool things with this particular tool, that you can extract the area which is inside a specified polygon, or you can extract the area which is lying outside of that polygon. Now you might be wondering where exactly is a polygon, because all we have over here is just a couple of points. Well, something to keep in mind is that if you were to create a polygon using these points, assuming that these points are the vertices of the polygon, you can see that if I draw a line from this point to this point and from this point to this, and just like that, if I were to connect all the dots in this manner, you can imagine that it creates a polygon, isn't it? So even though we don't have the option to directly add a polygon over here, what we can do is we can specify the vertices or the XY coordinates of each point, which basically creates a polygon. And ArcMap will understand that it's a polygon simply by making sure that we start with a particular XY coordinates and we can circle around until we come back to the same point, in which case we have to enter the same exact coordinates that we started with in order for ArcMap to understand that we have completed the polygon. So what I'm going to do is I'm going to minimize this for a second, and I'm going to open the attributes table of this points shapefile, and I'm going to see whether I can extract the XY coordinates of this set of points or not. And that's going to be done quite easily simply by adding a field for X. I'm going to make the file type, I'm going to make the data type to be double, and similarly I'm going to add another field called Y. That one is double as well. And simply I'm going to right click over here and I'm going to calculate the geometry, and over here all I'm going to do is just select the X coordinate of the point, and the units, we can set the units to be in meters, and that will calculate all the X coordinates. And over here I'm going to do the same, but the property is going to be Y coordinate of the point in this case. And now all I have to do is open up the extract by polygon tool, just like this, and make sure that you add this set of points, this set of coordinates over here simply by copying and pasting, and you can hit on this plus sign for it to understand that we have entered the corresponding X and Y coordinates. So this part I might fast forward the process of copying and pasting the entire thing. And just as I told you guys, one important thing to keep in mind is that you have to complete the circle simply by inputting the coordinates that you started with in order to conclude the circuit, which indicates ArcGIS that you are done with specifying the polygon, so it can consider those points to be the vertices of the polygon. Well, just to get started, let's go with the extraction area to be outside, because I think there are a number of tutorials where they show you how to extract the parts which lie, how to extract a part of a raster which lie within the boundaries of a polygon, but let's do it for outside for this case. And I'm going to specify my output path to be extraction outside.tiff, and we'll save that. And let's run this one and see what we get. So now if I deactivate the original elevation raster, you can see that it actually considered this to be a polygon, and it sort of cut a hole over here, and it extracted the part of the raster which lies outside of that particular polygon. And if I were to do the same by inputting the same set of coordinates, but if I were to select inside over here, I think you guys can imagine that we would not be getting this part, but instead we will be getting the part of the raster which lies inside the polygon. So I guess that's about it for this tool. I believe that it's quite clear for you guys how this tool works. And basically you can do this for any number of points, just that you have to make sure that you have the XY coordinates of the points in order to run this command. Alright, now let's move on to the next tool that we are going to discuss, and that's extracting raster values to points. Alright, what do I mean by extracting raster values to points? Now to demonstrate this tool to you guys, I'm going to use the same set of data again. I'm going to use this elevation raster and I'm going to use the same set of points. Now you guys can already know that this raster is basically showing you the different elevations, and if I were to zoom in just like this, and if I take this identify tool and if I try to identify the elevation value that's lying just below this point, you can see that the pixel value is 488. And similarly, I can do for this point, you can see that the corresponding elevation is 457. Now, just like this, imagine that we have maybe hundreds and hundreds of points and you would like to extract the corresponding elevation value from a raster to that particular point. Now, one way of doing that would be simply by doing this manually for each point. Just like this, you go and then you go over here and then you click on the raster and you obtain the pixel value, and that's basically going to be your elevation value. And you can manually input that into the attributes table of these points shapefile. Or you can use a handy tool that's already built into ArcGIS called extract values to points. So what I'm going to do is I'm going to go ahead and search for extract values to points tool. And from here, we can input this point features shapefile as one of the inputs. And of course, we can input the raster over here. And the tool is quite straightforward. Just one thing you have to keep in mind is that you have to have both of these layers in the same coordinate reference system. If not, this tool will not work. In fact, most of the geoprocessing operations that we did today will work only if you have all the layers that you were working with in the same coordinate reference system. Or after that, I can specify the output path, and that's going to be values to points, and it's going to be a shapefile. You can see that automatically the .shp extension gets added, and now we can simply click OK. Alright, now you can see that it creates a new shapefile, and if we open the attributes table, you can see that there's a new column called raster value. And this raster value basically corresponds to the elevation of the pixel that's lying beneath each of these individual points. Now, for example, this first point corresponds to this. If I were to zoom in and if I try to pick the corresponding pixel value, and as you can see, I think the pixel itself is quite visible. So according to this tool, it says that the corresponding pixel value is 313. So we can simply click on this pixel. And as you can see over here, it has extracted the value correctly. So that's quite a straightforward tool, extract values to points. And this can come in handy in quite a lot of applications. And I'm sure it's going to be useful to you at some point of time as well. Alright, so let's move on to the final geoprocessing operation that we are going to discuss today. And that's spatial joins and attribute joins. In order to demonstrate to you guys the functionalities of spatial joins, over here I have selected one shapefile called county names, and this county is actually belong to UK. And if I just open up the attributes table, you can see that we have a number of counties over here. And in the next shapefile, what you can see is basically the locations of the banks. Now, some of the bank names are present over here, but at the same time, you can see that some of the bank names are actually not really present. Along with that, you can see that there is another column called ATMs. Now, this is just a randomly generated column which shows you the number of ATM machines which I have assumed that each bank might have. And this was generated completely in a random way. So don't take this information too seriously. It's only for the purpose of demonstrating how to perform these spatial joins to you guys. So by definition, what spatial joins does is it joins attributes from one feature to another feature based on the spatial relationship. So let's see what that means with the help of an example. I would like to know how many banks are there for each county, as you can see over here. Now, if I were to count the number of banks which falls, let's say, inside the boundary of each of these counties, it's going to take me a lot of time. And over here, you can see that for this county, which is West Midlands, the number of banks are actually quite high. And of course, it's going to be a tedious task if I were to count each of these points manually. So I'm going to make use of spatial joins. So based on the spatial location of each and every point that you can see over here, I'm going to perform a quick calculation, and that's going to tell me the number of banks that fall within each of these boundaries of these counties. So what I'm going to do is I'm going to right click in these county names. I'll go to joins and relates and I'll select join. And what I'm going to do is I'm going to join data from another layer based on the spatial location. So I'll be selecting this. And over here you can see that we can choose the layer to join to this layer, and what I'm going to join to this county names layer is basically this banks layer, which is also loaded into my working space. And over here, how do you want the attributes to be summarized? I would like to take the summation. So when I tick this checkbox, it's going to give me the sum of all the number of points which fall within each and every county. And of course I can select the output location for my result. And I'm going to name this as number of banks. Well, it's going to be number of banks per county, and after that I can click OK and let the tool run. And after that you can see that we have a completely new layer called number of banks. And if I go to the attributes table, you can see over here it took the total summation of all the points for each and every county that you can see over here. And along with that you have the summation of the ATMs as well. Now if I open up this banks shapefile, you can see that certain banks have just only one ATM, while some banks have two ATMs, and at the same time the maximum number of ATMs that one bank has is actually going to be 3. So based on the spatial join, you can see that the summation of the ATMs is also present just along with the other information that you can see over here. Now if I want to do a quick sort, what I would do is I would just double click over here. And if I scroll down, you can see that the highest number of banks, as we assumed, if I remove this layer, you can see that this particular county, which is West Midlands, seems to have quite a number of banks actually compared to the others. And it's been proven to be true. As we look at this attributes table as well, you can see that the highest number of banks are 228, which belongs to this West Midlands county. And based on my assignment of ATM machines, you can see that the highest number of ATM machines are also inside that county, and that's 445. And similarly, you can see that this is the county which has the lowest number of banks. Let's see where that county is. Yeah, it's this county right over here. So the total number of banks are just 9. You can see that we have multiple dots over here. And the summation of the ATMs is 13. So that's basically the summation of each and every ATM that each bank possesses. So we get in total 13 ATMs. So I guess you guys got the basic idea of how to use the spatial joins. Now if I go back to this joins and relates, you can see that we have quite a number of different ways that we can summarize our attributes. But if you guys understand how to perform the spatial joins, if you understand the theory behind it, then I don't think it'll be that difficult for you guys to explore each of these different options and apply it according to your own specific needs. Alright, so I'm just going to leave the spatial joins just at that. And now let's go ahead and talk about attribute joins, or simply table joins. Alright, so if I navigate back to my folder, which is this folder over here, spatial joins and attribute joins, you can see that there's a CSV file inside. Now this is how that CSV file looks. We have the name of the county, and in front of that we have the area of the county in square kilometers. Now this could be any information. Let's say it could be the population, or it could be some other kind of information. So what I'm going to do is I'm going to make use of this CSV file, and I'm going to do an attribute join, and I'm going to take that area and put it over here into this particular shapefile as a new field. Now the main requirement that you have to have in order to perform this attribute join is that you have to have some common attributes in both the files. Now in this case you can see that I have the same set of names, and that's basically the names of the different counties, and even in my CSV file it's just the same. So I can simply perform that attribute join or the table join based on this common column. So let's go ahead and see how we can do that. So you're just going to follow basically the same step. You right click over here and go to joins and relates. Well, before that, maybe I think it would be good to import this CSV file into my working space. So I'm going to go over here to add data, and after that I'm going to add this CSV file. And now you can see that we have the CSV file over here. And if you would like to have a quick look at the CSV file, you can simply right click over here and click open. And you can see that this is how that CSV file looks. And if I right click over here and go to the attributes table of the shapefile to which I would like to make the join into, you can see that we have those two columns with the common attributes. We can right click over here, go to joins and relates, and go to join. And this time we are not going to do the join based on the spatial location of any attribute, but instead it's just going to be a simple attribute join from a table. And over here we have to choose the field in this layer that the join will be based on, and it's going to be based on this name 2, which basically consists of the different names of the different counties, as you can see over here. And as you can see, my table is going to be from this county areas.csv, and the field is going to be the name of the county. And before you actually perform the table join, you can do a quick validation just to make sure that everything is okay, and if there are any errors or if there are any warnings, you'll be notified. So for this case, I'm just going to ignore this warning, and after that I'll just simply click OK. And now if I go over here and open the attributes table, you can see that both of those columns from the CSV has now been joined into this county names shapefile. And just like this, you'll be able to join any number of different attributes from any table as long as you have a common column just like this. And after that, and now you can make use of the visualizing capabilities of ArcGIS to, let's say, visually represent any type of data that you would like to represent. In this case, it was quite straightforward. It was just the size or just the area of each county. We can go to symbology, go to categories, and now we can color the value field based on the area. If I go with a color ramp like this, you can see that the highest areas get colored in this kind of a light orange, and as the areas get lower, you can see that it's going to get colored in this kind of a blue color. And we can simply hit apply, and now you can see that, well, the counties with the lowest area is actually now being colored by these bluish and purple colors. Well, this is quite straightforward because we are dealing with areas, but this kind of a representation is actually quite helpful when you would like to display things like population, for example. And let me go ahead and get rid of this banks shapefile, so the data that we're trying to represent becomes a bit more clear. So that's basically how the table joins work. And that basically concludes this tutorial as well. And I believe that we learned quite a lot of things. And if you do have any questions regarding things that we learned, you can always comment it down below and we'll get back to you as soon as possible. And stay tuned for another tutorial like this, because there will be a continuation for this advanced ArcGIS tutorial where I will be showing you another different 7 geoprocessing operations that you might find very valuable when working with ArcGIS that can generally be considered to be quite advanced. So thanks a lot for watching, guys. I'll see you in the next one.